Okay, well, hello everyone. My name is Mike Anderson. I'm going to be chairing the session this evening. We're just waiting for one or two more people to join us, and then we'll get going. Okay, I think we'll make a start. We've got a reasonable number of people on. So thank you very much for joining. It's good to see so many of you on already. I've just been alerted that number 10 Downing Street is being listed as a prestigious location for short stays on Airbnb. So I'm glad you're joining us rather than watching the news. We're going to be recording this, so I hope that's all right with everybody who's on. The recording will be put into the public domain in due course, and the slides will be made available as well. What's going to happen is that John and Denis are going to give their presentation. Then we're going to open it up to a couple of colleagues of mine from the BCS who are going to talk about their UK perspective on all of this. You're welcome to put questions into the chat, and if they're questions of clarification, we'll try to answer them as we go along. Otherwise, we'll pick off the highest profile ones at the end of the session. And we're due to run until about 7, though we might overrun slightly if people are keen. I think that's probably all I need to say by way of introduction. So I'll just hand over to John and Denis at this point. And just say thank you very much indeed for coming forward and being happy to give this talk from the other side of the Atlantic. Very much appreciated.
Thank you for having us. Hi, everybody. I'm Denis Gagné from Trisatec, and I'm here with Dr. John Zwiberly, our Chief Medical Informatics Officer. And today we want to do a short presentation on modeling the preoperative surgical journey. But really our real intent is to give you an introduction to the notions of business process management for healthcare, what's commonly referred to as BPM Plus health. So our presentation today will go through an introduction of the BPM Plus health community of practice and what that means. We'll then talk about the models around preoperative surgical journey. And then at the end, we'll do a demo of something actually executing along those ideas to give you a sense of what the art of the possible is. Okay, so let's start by the intro to BPM Plus. So our goal here is really to marry a series of standards from 2 standard development organizations, the Object Management Group, OMG, and HL7. On the Object Management Group, we're interested in their process and decision standards, and on the HL7 side, we're interested in FHIR, CDS Hook, and Smart on FHIR standards. It's not necessarily an exclusive list, but it's the core list of what we're looking at in the context of today's presentation. So a little bit of basic terminology for those of you that are not really used to these notion and terms. What we're really talking about here is the notion of workflow automation and decision automation, and hopefully together. So workflow automation is all about orchestrating the activities and being able to react to business events as they occur. Decision automation is all about given a set of particular inputs, providing result output. Basically, think of decision automation as a Q&A or complex Q&A situation where the decision is about answering a particular question with an answer. To do so, we're using 3 standards that are produced by the Object Management Group. The first one is called DMN for Decision Model Annotation. The next one is BPMN for Business Process Model Annotation. and the last one here, case management, model, and notation. You notice they all have the moniker model and notation. It's because these standards all provide you with everything you need to do modeling, and also provide you with a visual notation to capture the knowledge that you're encoding in these standards. Now, all these standards can have human in the loops or not. So what we refer to as knowledge worker, and in the context of healthcare, probably clinicians and practitioners and all these different folks that may want to be involved in the flow of work or the flow of decisions. So DMN is more about capturing decision with decision table and logical expression. BPMN is more about prescribing a series of activity that must take place, yes, with variability, but we're prescribing. In this situation, you do that. In this other situation, you'll do this and that. Where CMMN is more about reacting in a context. So think of a particular context where events are happening and I'm reacting to these events in a more declarative way. So rather than prescribing, we're more declarative as to how we react to what's going on. Now, as I mentioned before, all three of these standards are visual. They have a notation that makes it visual and simple for people to grasp. This may be a little bit of an eyesore to look at the detail. That's not the intent. The intent is to show you that you basically in BPMN draw the flow of what you want to happen, to specify basically what may be, a clinical pathway. In CMMN, you have a context, which is that folder shape, and you're looking for different events triggering different tasks in a non-prescribed sequence. And in DMN, you have a decision that you decompose. Although it's shown here as a direct taxonomy, it's really a graph, so you can decompose this decision in many different ways and express the logic. And then within the process flow, you can call a decision or a case, and within a case, you can call a decision or a process, etc. So these all intertwine and work with one another. Now, another element that is important and interesting about all this is that DMN, the decision model annotation, specify an expression language that is called FEEL. FEEL stands for Friendly Enough Expression Language. And what's nice about FEEL is, first of all, it's a standard. So anybody using that expression language get the same behavior, the same semantic anywhere you use it. So when you put FEEL in the middle of BPMN, CMMN, and DMN, you then have a single expression language that is needed to express a particular decision point or logic that you have to express. Now, by combining BPM Plus with all the three standards, what you get is access to a very broad sense of what's possible in the coding world. So you can have the no code, drag and drop. What you see is what you get type of environment. You also get low code when you can actually specify expression that will be very specific, that drag and drop don't have the expressiveness for you to provide. Or you can have actual pro code, actual code done by developers that is embedded and invoked within these different standards. So it gives you a full access. A lot of people mistakenly think that if you're using BPM Plus, you're stuck in no code or you're stuck in low code. It's actually not the case. You can have the full range of access. Now, let me put all these things a little bit in context. I've thrown up a lot of buzzwords at the beginning and try to give you a sense of what we're looking at. So on this side here, we have the data. This data will come from different sources, EMR, EHRs, device, wearable, whatever, name it. And what we're interested at the data is aggregated data so that we can have a global view of things. Now, when we add something like FHIR, the FHIR standards, and I could have named, the open EHR archetypes, when you add those kinds of structure, then you have a common schema and identity resolution and resource, medical resource. And that gives us computable data. Now we have data that is computable, structured and computable, so we can do data automation on top of this. The value gets up as we add other elements. So as you add metadata and context and event awareness through things like CDS Hook or Smart on Fire, then we have information. So data in context is information. So now we can do information automation. And this gives us the data in a clinical context for doing this automation. And what we want to do is augment all this with BPM Plus so we can do the orchestration of knowledge. And knowledge is basically applied information. So we have workflow and decision automation that will take into consideration tasks and activities, roles and responsibility, decisioning, case management, and maybe a little bit of AI and ML, machine learning thrown in that. This is my buzzword bingo call. You can't do a presentation this year without saying AI in it. So I've said it twice, I'm gonna re-say it again. Yes, you can have AI in there. Or other languages or approaches such as CQL, the clinical quality language. And I would argue that all this combined together progress you towards what's really intelligent healthcare automation. So we'll try to give you a sense of what all this together means and maybe convince you that this is a way to actually get to intelligent healthcare automation. I will now pass it on to John, who will walk us through the particular example today, the preoperative journey. John?
Thank you, Denny. Thank you, Denny. So we're going to be talking about the preoperative journey. And this is a concept map showing the various parts of the various tasks that need to be performed. So at the top, we have the preoperative phase, and then you end up with really three separate stages in the preoperative journey. One is selecting the patient. The second is getting the patient ready. And then the final one is just before surgery, there's a number of tasks that you need to do. Now, one of the challenges for modeling it is that this can go very fast, or it can take months or even years to complete the cycle. So you have to have something that's robust enough to handle this temporal uncertainty. If we look at patient selection, you're talking about having three basic tasks. One is the patient has to agree to the surgery. If they refuse surgery at the start, you're not going to go further. The second one is to determine, are they unfit for surgery? And then finally, we have something in the United States called pre-authorization, which means that you go to the insurance company and the insurance company agrees that the patient can have surgery. If it's refused, then the patient doesn't go to the surgery. Now, in countries where you have a health service, you may not have insurance determining it, but pre-authorization actually handles four separate tasks. One task is that it looks for indications for surgery. It looks for contraindications for surgery. It looks for confirmation that surgery is justified. And then fourth, it says you've tried other things ahead of surgery because surgery is invasive and has potential complications. You want to be sure that only people who are have more likely to benefit than have a hazard go forward. So patient selection is basically a gatekeeper to the whole process. Once the patient is selected, you go to getting the patient ready. And this overlaps four basic topics. One is the one that most people are familiar with, which is rehabilitation and handling of comorbidities, which is highlighted in yellow. You also have a set of operational issues, such as patient education, informed consent, financial preparations, rehabilitation. A variety of things happen from an operational issue to make sure that the patient's surgery and recovery goes smoothly. The other aspects that we've added are for looking at risk. So one is risk of surgical complications, such as surgical site infections or wound dehiscence or some other factor that a person goes to surgery. It's generic to surgery. And then you have the risk of postoperative organ dysfunction, say heart disease, respiratory failure, gastrointestinal dysfunction, stroke or neurologic complications as a result of surgery. When you have this, the end goal is not so much to have a prediction that's very precise. It's mainly to highlight the patients who might have a problem going forward. And so if you have a person who's healthy, these will show very low risk. If you have an older person with comorbidities, several of these things may fire. And the firing of a person becoming high risk means that should the doctor refer the person to a specialist for evaluation and do some type of intervention to reduce the risk? Should they consider a different type of surgery, something that's not invasive, but to go to laparoscopy? Should they use general surgery? Should they use a regional block? There's a variety of things that surgeons can do where if they know a person is high risk, they can make interventions to reduce that risk. And so that all feeds together. Also, it feeds into the informed consent, because a person who is high risk might need more conversations to explain the pros and cons of having the surgery. And I think that the prehabilitation for sure has proven to be a significant factor in improving outcomes for people who go to surgery. Then finally, we have the immediate preoperative preparation, where we're talking about things such as deep vein thrombosis prophylaxis, antibiotics to reduce infection, coordination of medications, and tasks like that, which are done usually within a few days to the day before surgery, where they're topping off the patient just before they go to surgery, so the risk of complications is lower. Some of these, such as the risk of the need for blood, DVT prophylaxis, antibiotic prophylaxis, are all things that may be fed from things that you've learned further upstream. A person who has a higher risk for deep vein thrombosis might get a higher level of intervention than someone who's low risk. So all these things can guide you so that you personalize the care that the patient is given. So if we go to the next slide, we can see how.
John, basically, the point here is that the preoperative journey is very vast. There's a lot of element in place, and there's a lot of variability that each individual patient gets a journey that is fit for his own particular situation.
And the unfortunate part about some current healthcare is that because there's so many steps, some steps get omitted for a variety of reasons. And it's only after something goes bad that you say, well, I should have done something. So the goal of having something explicitly stated, as you say, in a prescriptive sort of manner in some aspects, is that you can head off any problems before they occur. And that is just, it's good.
Excellent.
Okay, so I mentioned that one of the problems we have with modeling is that the entire preoperative, intraoperative, and postoperative stages can take a prolonged period of time. In emergency surgery, it might be very fast, but for elective surgery, such as a joint replacement, where a person might have to lose a significant amount of weight, it can be quite a long process. And so this shows a CMN process and shows the various stages where we have the patient selection to the left, we have the patient preparation in yellow, we have the immediate preoperative phase, you have surgery, and then you have the postoperative where you have early recovery, late recovery to discharge, and then the rehabilitation in the community. Now, we diced it up this way. You could dice it up in other ways. For example, the immediate preoperative phase, surgery, and early recovery all tend to occur within the context of a health system. And so it's also possible to model it that way. By having it broken up into discrete units, you have the flexibility to decide where things go. Next slide, please.
And this is presenting really a conceptual idea of this, but what's important for people to get from this is not necessarily, you know, this nice little linear skew, because that's not how reality works, but what we're trying to capture simply here is that when you're using CMMN, you can do kind of a life cycle management notion where you're going from stage to stage and manage this life cycle and the complexity of it. We did a simplified version here. There's a lot more complexity under the hood of all of this.
Right, and also what we're trying to model is the happy path, where a person goes through, as anyone who's done clinical practice knows, all sorts of curveballs can appear. And so those are very, very hard to model. But a very large percentage of people do follow the happy path. And so if you can expedite or improve their care, it can have impact to the healthcare system. When we look at the area, and what we're doing now is honing down to the topic we're going to show the demo for. So we've talked about the high level. Now we're honing in on one of the phases for prehabilitation. And this has two parts. One is the correction of lifestyle factors, which is on your left. And then the other is addressing comorbidities that might be present. So for lifestyle, you might have a person who's deconditioned might start exercising. A person who's malnourished or with poor diet might improve their diet. If they smoke or drink, they may want, they should stop. And if a person is anxious, then they can undergo counseling to help them deal with the stress of surgery. On the right, we have comorbidities that might be present, and anemia is what is highlighted in yellow, and that's what we'll be showing later. You can have handling of active infections, because the presence of an active infection is one of the primary risk factors for postoperative infections. And then you control active comorbid conditions or other conditions through medications are all there to be considered. And then finally, you want to do an assessment for frailty, because especially an older person, when they go to surgery, can have deterioration, become frail, and you want to know about that before they actually have the surgery. So if we look at anemia, then I believe we go to the next one.
So just adding here, while the previous slide was showing how we can use CMMN to manage life cycle of stages, this particular slide here show how we can use CMMN in a very declarative way. We don't know which order these things are going to happen. We don't know if they must happen or must not happen. They may be optional. So here you see more this declarative event, condition, action type of situation in CMMN. So while the first slide was more about life cycle of stages, here you have the notion of being declarative and reacting to particular events in whatever order they may come.
And one other thing is that if you notice, there were little icons on each of the tasks, and that indicates that each of those tasks can call CMN model, BPM model, DMN model as needed to meet the requirements for that task. Now, when you look at anemia, something that often happens is that an older person or middle-aged person may have anemia. People who are anemic, one, are more likely to need blood transfusions. They also tend to have more complications for a variety of reasons. So a common goal is to identify a person who is anemic, identify the cause of the anemia, and then try and treat them so that they have as high a hemoglobin as they can get before surgery. And so that might take a period of time, depending upon what, if there's a nutrition requirement, what needs to be replaced, or if erythropoietin is required, some type of intervention might be done. So this, it's important to find anemia, and this is a model that's a BPM model to help us do that. So if you have a patient come in to see the surgeon, he'll first do a clinical exam. Then based upon the clinical exam and laboratory testing, he'll decide if the person is anemic and what severity it is. And for that, we're using a decision based upon guidance from the WHO. And then once you decide that, well, the person, then after that stage, which is in yellow, you go to a gateway, which is conditional branching. If the person doesn't have anemia, you don't care, and out you go. If, on the other hand, the person does have anemia, you want to know what could possibly be the cause. And so in hematology, there's a number of ways of quickly triaging the 60 or 70 causes of anemia into smaller groups. And one of those is look at the MCV, or mean cell volume, and RDW, or the red cell distribution width. And those use laboratory values off the common CDC and basically say, does a person have a microcytic anemia, a normocytic anemia, or macrocytic anemia? And for each of those branches, there's a further workup that's specific for that branch. Next slide, please.
So here you notice that when we're switching from CMMN to BPMN, we're much more prescriptive. We can have variability. For example, we can have multiple branch, and this is a simple example because we want to convey the idea, but this can be quite complex, but you are prescribing what to do in the condition where anemia is detected and what to do when it's not detected. So you're being very prescriptive about what should happen when and what should happen because of the context.
And one other thing to mention, when you look at these models, you'll notice that some letters are in red with an underline. And those terminology can be linked to a knowledge entity model where your terminology can be standardized. So when you build a model, you can create a link back to your terminology. So if a person says, what does hemoglobin in grams per deciliter refer to? You can explain what hemoglobin is, what you can give the various flowing or SNOMED codes that might be involved. And all that makes sure that everyone's on the same page in the process. And finally, we have a DMN model here, which basically takes the WHO algorithm and uses age, sex, and hemoglobin to decide, does this person, based on age and gender norms, have anemia? And if they have anemia, is it mild, moderate, or severe? And
so here, when we're moving into DMN, you see what we're depicting is the decision here at the top, which is basically the question we're asking, what is the anemia severity according to the World Health Organization for this patient? The inputs are the age, the sex, and hemoglobin, and these are information requirements. So that what this is saying is, to do this decision, I need these 3 pieces of information as a requirement.
And then if we go to the next slide, we have a decision table that uses those 3 bits of information to reach the final classification off to the right. So across the top, you can see you have the age, you can have the sex status and hemoglobin, and then each of the possible combinations are laid out until finally to the right, where you have anemia severity in the second column to the right. That's where it says there's no anemia, mild anemia, or moderate anemia, all of which can be useful information.
So things that are important to notice here is we're using decision tables. So one of the powerful way of capturing logic in DMN is through decision table. It's not the only way. There's all kinds of other what we call boxed expression that are possible. But here we're showing this one because it's the one that is the most popular and most used. And basically a decision table, you can read each row as a rule. So if I read each row, the first row says, if the patient is of age from 0.5 to 5 years old, I don't care about the sex. And if the hemoglobin is over or equal to 11, then there's no anemia severity detected. So you can read each row as a rule. So basically you can see here that according to the World Health Organization guideline for anemia severity, there's 24 rules that are captured here in a single visual diagram. The little dash just means don't care here. So I've broken it up so you could see the breadth of it. So you can see here how you can, in a very simple visual way, capture some logic that may be quite complex to explain to people.
And decision tables are very useful in a lot of healthcare scoring in many situations. But as Denny said, there are several of these 6 or 7 box expressions that are accessible. You can have equations which follow the field expression language. You can have more formal rule-based systems. There's all sorts of things that you can add. So you have a really robust system. Also, your data can be a structure, which means that you have not only complexity, you can have simplicity or complexity in data, but you can also have simplicity or complexity in your analysis, which gives you a nice environment. So this just summarizes what we have. One of the goals, one of the questions about building the models is, are you building for documentation, for education on the one hand, or are you building for automation? When you build with these things, you need to know that when you're designing it, but the same artifact that you're generating can be used on the fly to generate documentation. It can be used to generate educational material. It can be used to produce software that can be automated. So you have one artifact, that's the only thing that needs to be maintained. And although it can take work to make sure that it's all there, it's still more efficient than alternatives in handling complex systems.
Yeah,
and I believe
and what's important here to understand is that you have a single artifact to manage. So it's not like you have to manage, you know, the moving from L1 to L4, etc., and version each individual artifact. Here, there's a single artifact that is just growing. So the actual model, when it's properly documented in the model, becomes your actual guideline narrative. The model is also the guideline specification of the logic. It's also the execution code. So it's both human and machine readable as a single artifact. Now, we're making it sound very simple here and showing all this, but there is naturally complexity behind this. For example, John, how many models were needed to create the preoperative journey?
About 80.
So the journey is not just one model. Each aspect is separated, and that's actually a good architectural practice, because when you do this separation of concern and you isolate these elements, then you can have reuse. So, and this reuse is very important, so we don't redo things in a slightly different way all the time. We have a single way of doing the same thing, getting the same conclusion. And so if this is modified as it evolves through time, it always evolves, there's then a single point for us to go modify. So, and that's why here we were showing you with the yellow highlight as we were going down the hierarchy of all these models. So the first slide was basically showing you 80 some models that are involved. Then we dig down to the last model for anemia and down to the World Health Organization decision. So these can then be reused by drag and drop because of this visual approach. Is once this logic is captured, I can drag and drop it and reuse it in another context.
And also another feature is that when you build several systems, there are inherent patterns in the practice of medicine. And so although you might need to build a lot of models, it's often a modification of a pattern that you've already done. So it may sound somewhat large because of how things crystallize. It's less of a major undertaking than you might otherwise expect.
So let me jump into a quick demo of these notions. So let me go right into the anemia model that John was showing in the slides here. So as he mentioned, all the terms that are underlined in red here are disambiguated terms. That is, that there is a definition, it is a control vocabulary that we're using in our environment, and we have the definition available. And this is in what we call a Chem model. So the Chem model, which is a knowledge entity model, allows you to draw conceptual diagrams on how things are interrelated to one another and with the definition. And this gets populated back with what we call fact types. So you can see here that for the word anemia, I have a series of fact types or relation at the bottom that are basically extracted from the diagram. And plus, when we're in the healthcare specific context, we can further disambiguate the term by specifying the source where this comes from, but we can also add coding. So we can add value sets or specific codes. So in this particular case here, John has disambiguated this term with this particular SNOMED code. And naturally, you can edit and augment this as you choose. So now when I'm in the context of this model, when I use the word anemia here, it's completely disambiguated all the way down to the semantic meaning according to medical coding, whatever that particular medical coding may be. So there's less chance of misinterpretation and usage. Now, here you see that this particular decision is using a decision model. So this is the World Health Organization model that John was talking about, that we presented, and the decision table here. Now, what's interesting is I can generate a report from this, and then I'm going to get my fully documented narrative about anemia assessment. So that's one interesting thing. The other interesting thing is that I can actually publish this. So if I go under execution here, I can take this model and deploy it. And when I deploy this model, what the tool is doing, it's taking this model and all the definitions of the objects and their data type and their coding and all this, and it's bringing all this together. It also pulls out all the dependencies. So for example, this model here requires those two decisions. So it's pulling these decisions and it's generating for me a service. So when I actually publish this, I get a service that is for my initial anemia. And the tool generates on the fly, because we have all that information, can generate on the fly a form for me that let me consume that service. So you see here, because we know that we need the age in years as an input, and we know the age in year is a value between 0.5 and 125, that's what I'm asking here. So this is all introspected for the IT folks in the group there. We can do introspection of the model to know what's required to run this model. Now, the tool also generates on the fly a REST API, a fully documented REST API. So now this model is a service that I can actually execute and I can test with fully documented API with the 202 code returns and etc. for all the different aspects, my 401, my 500 return. So I have a fully documented REST API. We also have what's called an open API file. An open API is a standard that specifies what are the parameters of the service, what are the input parameters and the possible values, what are the output parameters and the possible values. So it's a specification of this service. And in fact, this open API file can be used to generate or dynamically generate interfaces. So this form that I just showed you is one of those. It's a dynamically generated form based on the open API definition of that service. Now, we also have healthcare integration endpoints that are added in there, and I'm going to talk a little bit about this next. So let me move into my environment. So here I have a small demo rig so people can grasp all these concepts. So on the right hand side here, I have this kind of mock-up EHR or EMR type of environment where I have my patients with different condition and observation, and I have all my data on my patient, and I can switch from one patient to the other. Now, my specific EHR EMR here has the capability of using CDS hook. That means that I can drop into here a particular hook. Now, if I go back to my service library and I go and copy my CDS hook endpoint of that service, I can then come and drop it here as an endpoint. And when I save it, now I'm getting a CDS card back every time I switch patient. I've made the hook on the patient change. So every time I change the patient, this logic here takes place. So I check all this, I do the world grade if there is and you see my card is telling me that in fact, this particular patient has moderate anemia severity, and those are the possible type of anemia she may have. And as I switch from patient to patient, I'll get different results for that particular service that's running, all the way to a patient that has no severity at all. Now, so this shows you how the same model can be used to be consumed within a form kind of environment, be consumed as a REST API, be consumed as a CDS hook, but I can also look and I can consume this as a Smart on Fire app. So imagine I don't have that CDS hook. I can actually make it disappear. So let me just delete my CDS hook. Oh, that wasn't a good idea. Anyway, the reason it's not a good idea is I won't be able to show you the comparative results. So let me put it back. So it's back. Now, and let me go to a patient that has a little bit of data. So for Cynthia Wilson, she's got moderate, and those are the two types of potential anemia she may have. Now, if I go into Cynthia Wilson, and let's say I don't have the hook, I could start a Smart on Fire app that consumes the same model. So when I run this Smart on Fire app, the authorization is taking place, and then I get my results, which is running outside of my EHR, EMR. So you can see I have the same result in the Smart on Fire app. Now, I also created another version on the Smart on Fire app. We were talking about putting the clinician in the loop. So within these different tasks, it's possible in the TriZetec platform to add an attribute that is called attended task. And with attended task, if I mark a task as attended, it will offer to the operator, the knowledge worker, the clinician, to confirm either the input or the output or both. And as I do this, now if I run the Smart on Fire version of the attended anemia, you'll see that now, rather than providing me, oh, something is going away here. Okay, let me retry. There we go. So now you can see that rather than just giving me the results, the tool is asking me to confirm the data that it pulled out from the EMR EHR. So maybe, well, by now my patient is 73 and she's non-pregnant, but let's say her hemoglobin is now 11.5. And I'm not medical, so I may enter things that are stupid. And if I do, then it tells me that she's got mild anemia as the conclusion from the decision. But I could say, I don't agree. I think she's got severe anemia. And then it will go on. And then I can do the same with the MCV and RDW. And then now you see, rather than when I run it here, it says moderate of these two. Now the, oh, this is the one I was running. The actual clinician decided that it was severe as opposed to moderate. So using the same model, so there's only one model to capture, and you can then have all these different behavior. It gives you a full sense of what's possible with BPM Plus type of environment. So, oh, and I killed this unintentionally. And if I do this, will it take me back to where I want? At the beginning. Sorry for the dizziness. And that's basically the conclusion of the presentation. I know John and I provided you with an awful lot of information very quickly. This is drinking directly from the fire hydrant. But we hope that we've given you a broad sense of the art of the possible, all the way from the breadth of what you can do, like the preoperative journey, which is quite a large breadth of model and variability, how the different standards can be used to capture different aspects of that variability, and how these models, once created and fully disintegrated, can be deployed and consumed in many different contexts in many different ways. We're open to questions, or maybe Mike, you'd prefer to go to a roundtable first. I'll let you guide us.
Well, I think you've absolutely stunned the audience, because we haven't seen any questions in the chat, but I have to say that was absolutely superb, very worthwhile, and thank you for squeezing so much in such a short time. As the famous science fiction writer William Gibson said, the future is already here, it's just not evenly distributed. And this is streets ahead of some of the things that we've seen in other places. So I don't know if Nicholas or Tito wants to come in and say anything about how this might be applied in the UK, and or whether they've got any other comments.
Thank you very much for a fascinating talk. I mean, I do have one particular question, and that is around sort of the potential benefits of BPM Plus without the automation, just using it as a tool to document. I just wondered whether you had any views on whether that might pragmatically be the first step towards benefiting from BPM Plus.
Yeah, I think it, as John mentioned as he was presenting, you can model for documentation purposes and clarification and disintegration, or you can model all the way for automation purposes. And yes, you're quite on point. And in fact, the BPM Plus Health Community of Practice just last month had a joint meeting with the HL7 group. And during that meeting, what was explored in many different contexts was how, for example, how the BPM Plus type of model, BPMN, CMN, and DMN, could be used to provide guidance and context into the implementation guides. So rather than just describing what's going on, have a model that depicts what's going on to further augment the implementation guide. But you can also imagine some of the bodies that generate guideline that could start generating their guideline in this way. It would make them less ambiguous and very less prone to gaps. And I'll maybe pass it on to John to talk about the problem with the narrative guidelines in general.
Well, I think it's only when you start actually trying to implement the guidelines do you realize gaps that are present. And there's a variety of reasons there may be gaps. One is that you have a process that is done by consensus of a group of people. It's also, and I think we mentioned the NICE system before, a lot of times these can be, the guidelines when they're produced can actually be quite large. And as a system gets larger, you end up having reader fatigue. So people at the periphery, they do very well in certain areas, but as you get to the periphery of the topic, they tend to leave things out. And it's only when you actually have to make a model that's explicit that you realize there's a gap that's present. And I would posit that the complaints that many doctors do not follow guidelines may be based upon the fact that guidelines are very hard to follow as they're published. Very valuable, but they're not explicit enough in what they do. And having them done as models could help people fill those gaps.
Thank you. Just out of interest, in the US, are there shared repositories that have started to be built using these models?
Well, it's not just in the US. So it's happening also in Australia. It's happening in different regions. Right now, most of the models are created within the firewall of the organization. So I don't think we have moved yet. The BPM Plus Health community is building public domain models and making them available for exemplar and reference. But the various organizations are building their own models and using them internally. And in fact, some of these organizations are looking at monetizing this knowledge, this basically captured knowledge, so they can say, well, if you want Mayo Clinic's best practice, you can have it. You want Telstra Health best practice, you can have it. and maybe monetize these model and these automation services in that way. So we're still early in the global adoption, but many organizations are quite advanced in using these kind of concepts as they go forward.
Thanks. So while you've been talking, we've got some interesting questions in the chat. I don't know, Nicholas, if you want to just jump in quickly and say.
So if that's okay, yeah.
Yeah.
So I think one of the important points that Denis and John have illustrated is the composability of models, and the fact that it's about composing a full pathway from really quite micro models at the low level. So I probably ought to say who I am, Nicholas Orterbridge, the lead data architect for NHS England. For me, the key thing is how we can harness the models that already exist, but almost certainly aren't in the representations that we have here. I think the point about making NHS-owned models available to the wider health community is important. People on the call will have been contributing to the FCI consultation for our draft standards for interoperability strategy a few months ago, and I'm hopeful that will come out. But that representation of some parts of the models was clearly called out in that, in terms of the models that are used for user interfaces and some of the triggers that are used to initiate those. That's not the full BPM Plus stack, but it's a component of it. And starting to build those using international standards to represent both the structured data capture or the FAR questionnaire possibly, or whatever it is that we choose to use for the data that is the input to workflow and decisions is a really important stage. And was in that. The strategy didn't go as far as saying we will do full process modeling and analysis and going a full BPM stack. And that was a conscious decision based on where we thought the maturity of the market was, and that we didn't think that the NHS as a whole was ready to move that full distance. But getting that shareability of what we already have as our assets is really important. And I think the point you made about intellectual property is really important. And intellectual property brings with it rights and responsibilities. And I think there are a couple of reasons why people are keen to be documenting intellectual property rights and responsibilities up front. Not least of which device regulation, because quite a lot of these models will count as devices in a number of jurisdictions, and of different severities, particularly when you shift into the direct execution to calculate new knowledge from existing knowledge and to present complex calculation. But the second thing is we already have a very good market for sharing form templates, particularly within the general practice setting. And we have thousands of templates which are exchanged between general practitioners' systems and between and often authored by specialist teams who author input templates and with decision capabilities built into them. Getting those into a common representation is something that we will be looking at over the next year, and then building a library with intellectual property rights clearly identified on those libraries, those entries in the library available. So yeah, that's really what I wanted to add to that one, but I think it's really important that we get those journeys described well.
Okay.
Yeah, and I totally agree with your different point. On the maturity level, that's maybe where I'll be a little bit controversial, just for the sake of conversation. If Steve Jobs would all say, well, it's not time to introduce the iPhone, the market is not mature for it, we would still be using our Nokia with our keypads.
So,
at one point, somebody's got to take a leap of the art of the possible and leapfrog the migration, because the migration may be very long and painful. So at one point we have to decide to leapfrog some of this.
I don't disagree with any of that. The standards for interoperability strategy was actually saying where people will be using exactly the same thing. And I don't think we're yet ready to say everyone uses the iPhone.
Yeah,
or indeed
understood.
many of the proprietary standards like Lightning that drive the success of the iPhone. And in fact, the Lightning connector seems to be dead now.
Thanks, Nicholas. We've got a few more minutes, and I think it'd be good to get onto the questions in the chat. I guess you guys, Denis and John, you can see those questions. Would you like to pick them off in any order you like?
We can just pick them off in the order they came. So
yeah,
the first one was, thanks for a fascinating talk. Can you model different pathways for different operations? Yes. So fundamentally, the model we showed you are supposed to be expressing all possibilities so that each instance of the model takes a different path. So for example, if you notice, when I ran on some patient, it said, here's moderate risk and here's the value. And for another patient, it said no anemia. So in my two branch, depending on the patient particulars, it's taking a different branch. So the answer to that is yes. You want to capture that variability. And sometimes it's not possible to prescribe all the possibilities, which would be in BPMN. And that's where CMMN comes in handy. So you don't have to prescribe everything. You can just say, well, if this happened, we'll react this way, as opposed to trying to say, after this, when this is done and that is done. Next question. How are exception handled, e.g. you reach a point where the model is not sufficiently detailed for the complexity of the problem that the patient exhibit? I guess the easy, quick answer is through that attended work, as I've demoed, where the knowledge worker, whether it's a specialist, clinical nurse or whatever, can interrupt the work and do different things and impose different things and enter different values. So you can always rely back if you're not already relying on a clinician looking and confirming what's going on.
And also, I think which end up will need in the future probably is some type of human software interaction, because the software is modeled for the happy path. And although you can model all exceptions, it just as things get more and more exceptional, the burden of modeling gets higher and higher. So you're spending more than you're getting back in return. And often you want to hit a careful balance where you have efficiency yet clinical robustness. And at that point, that's why you need the clinician to be there to realize that the model isn't quite right and that he or she has to take over.
And I think the one that goes on to that, John, is that gathering consensus on fine detailed clinical practice is very difficult to do because the number of people involved is tiny who actually encounter those.
I think that's where, again, how you represent it, because you can do a model like this for surgery, which covers a very general one, but there in practice be quite a few deviations. And something that might be actually more useful for practice is the use of microservices, where you have little services that are waiting for events to happen and they can automatically be triggered to alert the clinician that there's a problem. So how full automation would be, that's a ways off, but you can start introducing this in ways that can make an impact to practice.
And CMMN is the way to introduce those kind of microservices type of architecture, where you have this event condition action type of pattern, where a particular event is a particular morbidity, a particular value of data comes in, it creates a reaction, and then other things trigger other things. So again, as Nicholas mentioned, you want to decompose this and have your smaller pieces of element that you can reuse in many different contexts. Next, two questions. how do we model non-deterministic NLP decision support? I'm assuming you mean natural language processing, decision support based on analysis of non-coded data in records and letters. So that first question, that is a challenge of the general field globally. We're getting very good in technology in doing natural language understanding and processing. In fact, it's quite advanced. We're doing some work at Trisatech. I presented at Decision Camp a few weeks ago, some work on natural language understanding about what we call situational lifting, which is to take the different concept, do concept lifting at the semantic level, and then assemble these concepts into a higher semantic context so that it can be used within a context. So there's a lot of research going on those aspects, and that's certainly something we're exploring as well. And I guess you turned on your camera, you must have asked a question, so you may want to add on to your question if you want.
Thank you. And yes, that is a problem. I'm involved in some procurements for speech recognition with NHS Digital at the moment, and this was one aspect. And I suppose the question is, who's running the AI stack for the NHS, and questions like that, and how do we model that? So I'm pleased to hear that that's being looked at.
Yeah, and fundamentally, if you think of it, the natural language understanding will break out the sentences and will give you a tokenization of all these elements. And then most generic algorithm will be able to recognize at least some categorization of names, but it will recognize Denis Gagné and presenter as two names. So now you have to do conceptual lifting to say, okay, they're both names, but one is a person name, the other one is a role. And then once you have the name and the role within the context of the sentence, you have to lift it to your context. And your context in this case would be Dee's model, that says, okay, within this anemia model, I'm saying everything here, a presenter is supposed to do this and that step. So that's how you do this lifting, going from the low-level elements to higher semantical levels.
I suppose leading on from that, the question is, if from the data, say an adversarial or other model is derived, which you cannot necessarily predict the output from, but is better than the deterministic model which we've put in front of us. Let's take an example, say AlphaZero is much better at playing chess than anybody else. We're not quite sure how it does it, but we trust it to do the job. How do you model that in a healthcare context, given that that's a likely outcome in the healthcare domain? Oh,
you're scratching my back very hard here. Don't take me down the AI path, please. So some of the challenge we have, I'm a gray hair guy, so I'm from the generation of, I did my grad studies in AI in the 80s. So in those days, both symbolic and non-symbolic approach were already there. The symbolic approach kind of took the lead and then went into the AI winter. And now on the other side of the AI winter is the sub-symbolic neural network machine learning that's having their party. The winter is coming because most of these approaches are showing their limitations now. A lot of businesses, organizations are spending a lot of money that's going in the trash. Now, what seems to come back up is this neurosymbolic approach, where we combine both approach and make them as efficient as possible. So we use the sub-symbolic to do everything that has to do with perception and recognition. And then once we have that recognition, we move into the symbolic world, which is basically what the path that I was explaining before, this lifting, say, okay, now I'm happy that I don't know how the algorithm decided that this was a dog or a cat. That's fair enough for me. Now that I know that it's a dog or a cat, I want to symbolically treat that. So bring that in the context of healthcare. There's perception and identification that we're maybe happy to leave into a bit of a black box, but then want to turn into a symbolic that isn't explainable.
So it's a black box classifier in your schema, essentially. Just very quickly, I'm very interested in optimizing efficiency in business processes. We're very keen to improve throughput in healthcare. For example, using speech recognition will get you 5% of your time back in a paperless A&E department. So that's regarded as a bit of a priority at the moment. How do we model the process of optimizing interactions? I'm very keen on minimum entropy models, but in particular interaction efficiency at the human-computer interface based upon the type of guidelines that you're presented with. How do we make sure that we're not taking longer to achieve an outcome, even if the quality is going to be better?
Just before you answer that, Denis, I think if you could answer that, that'd be absolutely great. But then I think we'll have to draw it to a close because it's getting a bit past 7. Fascinating as this discussion is. So I think it'd be great if you guys could carry on afterwards. But if you'd like to just briefly respond now, Denis, that'd be great.
Okay, well, fundamentally, what we've seen, so BPM Plus, or this notion of decision and workflow automation and modeling, is not been created for healthcare. It's been around for quite a while and used in many industry, agriculture, manufacturing, finance. And what's been shown is, in fact, something that Tito and Nicholas were pointing, is that 80% of the value is in first documenting the thing. Getting people around the table, starting from a narrative or a situation, trying to model it, then people realize, oh, that's how we do it? I never realized we were doing this. Oh, are we forgetting this? So there's a lot of value of just capturing in a formal, structured way. So right there, you get a lot of value, probably the 80-20 there. Now, the other benefits come to say, wow, look at the spaghetti mess we just drawn that's reflecting the reality. How can we simplify that? So there's a lot of different techniques, either manual or automated, to simplifying these kind of spaghetti environment to make them more straight through. Now, once you have this straight through, clean way of getting to the same result, then it depends on the particular context in which you want to use it. Whether you want to use it in a purely straight through processing automation context, or you want to use it in a user environment where interaction, and then this is a balance that you have to achieve. So there's no one answer. Each case got to be treated specifically in the context in which it is used specifically.
Thank you.
You're welcome.
Thanks very much, Denis. So as I said, I think we'll need to draw it to a close. That'd be great to carry on. That was a truly exceptional talk and presentation, genuinely so. Very pleased that you gave it to us, John and Denis. So I think we just need to say thank you very much again for a fantastic talk, and hope to see you again sometime, because I think this is something that's well worth following up. So thanks again, and thanks everybody who participated, and thanks for the questions. And we'll be having another BPM webinar in due course. We haven't scheduled it yet, but we'll let you all know.